or 53?
52 is correct. Okay, so 52 is correct here. We're just going to 250, and then we're dropping it down from there. So 250, drop it down, and you'll get 52 grams of sugar. So when we're looking at scatter plots, we want to be able to identify the correlation that exists between the scatter plots. So if we're looking at our 3 different scatter plots here, you can notice in the first scatter plot that the values are going up from left to right, which represents a positive correlation. Our second scatter plot would have a negative correlation, and our third scatter plot would have no correlation. So if you look at the third one, you'll notice that there's no pattern between our values right there. So that would represent no correlation. Our second scatter plot in the middle, the dots are going down from left to right. So that represents a negative correlation. And then our left one represents a positive correlation. The values are going up from left to right. So if we're looking at these 2 examples, we can see obviously in example A, the correlation is not that strong, but there is a general pattern of the dots going up from left to right. So that would be a relatively weak positive correlation. Here we can see a much stronger correlation between our data values. They're going down from left to right. So that would represent a negative correlation. So I want to show you on Desmos how to go about making some of these scatter plots to determine whether or not there's a positive, negative, or correlate or no correlation. I did this in the video, but just to remind you how to go about doing this. So we're going to go to Desmos and our graphing calculator. So if you just go to desmos.com and then click on the graphing calculator, and we're going to enter our data into Desmos. So in this particular problem, oh, I don't want Excel. Sorry. I'm going to put my temperature as my X values and then the attendees in thousands as my Y values. So 82, 78, 68, 87. Let's enter that value in. So to create a table in Desmos, hit the little plus sign and then a table. So we've got 87, 78, 68, 68. 82 is the first value, my fault. 75, 71, 92, and 84. And then our Y values are 4.5, 4.0, 1.7, 5.5, 3.8, 2.9, 4.7, and 5.3. Okay, so you'll notice you can't see your scatter plot right away because it's outside of the range of the values. So we're gonna have to zoom out a little bit. So let's zoom out. And now we can see our scatter plot right there. So obviously you can see your points, generally speaking, are going up from left to right. So obviously we have a positive, no problem. I know a lot of you had your power out. So you see that there's a positive correlation here between our data values. Okay, so that's how you would go ahead and create the scatter plot. We can do this one for this one as well. I don't think we need to go through that process. I think most of you are pretty clear on how to go about doing that. So within a scatter plot, the next thing that we care about is creating a line of best fit, or a line that helps to model the data. So when we're creating that line of fit, we want to create the line that's what's called the line of best fit, meaning that it's a line that models the set of data most closely. So in creating that line of best fit, on Desmos, in order to create the line of best fit, which is in the video, and I posted another video today that goes through that, you're going to do y sub 1, and then the little squiggly thing that looks like the accent tilde, which is next to the letter or the number 1 below the escape key. So you have to hit shift and that little squiggly. And then you're going to do mx1 plus b. And that's going to get you the equation of the line of best fit. So you'll notice here that your m is 0.1368. I'm going to round that to 2 decimal places, so 0.14. And your b is negative 6.85. Notice there's another thing that we care about, which is this thing called the r value, which is 0.8825. So let's write a bunch of things from this problem. This is where we're going to get our line of best fit, our equation that best models a set of data. So for this particular problem, your line of best fit is y equals .14x minus 6.85. We know obviously that there's a positive correlation here. We saw that from our set of data. So there's a positive correlation. And we have our line of best fit, our equation that best models that set of data. When you're asked about this line of best fit, okay, you might be asked to interpret both the slope and the y-intercept. Now, sometimes the slope and the y-intercept don't really have values that make sense. When you're asked to interpret the slope, you're saying for every increase in one value of my x, what's happening to the y values here? So when we're talking about our slope interpretation, we're saying, okay, for each increase in one x value, which in this case in 1 degree, what's happening to the y values? So our y value is the attendees. We would say that the attendees are what? Are increasing by 0.14 thousand. So when you're asked to interpret the slope, you're saying, okay, for every increase in 1 for our x, what's happening to the y? So for each increase in 1 degree, the attendees are increasing by 14,000. And this interpretation of slope is posted on Classroom on the post for today. If you click on today's post, you'll see interpretation of slope is right here. For every increase in whatever our x value is, the y increases or decreases by whatever the slope amount is there. Okay, so for every increase in the husband's age, the wife's age increases by 1.07 years. That's another different example, not on the problem that we just did. But that's how you want to interpret your slope. Now, in terms of the interpretation of the y-intercept, and again, this is all for this problem right in here, your y-intercept here is negative 6.85. Now, keep in mind, the y-intercept means that your x value is equal to 0. A lot of times, your y-intercept doesn't make sense in the context of the problem. This would be an example. Because you're saying, okay, if the temperature, meaning your x value, is 0, the attendees is negative 6.85 thousand. Now, obviously, in the context of this problem, this doesn't make sense. That says sense. Okay? So if your temperature is 0, the attendees is negative 6.85 thousand, that doesn't make sense in the context of the problem, which is something that happens a lot when you're dealing with regression and things like that. But make sure you're comfortable with interpreting the slope and the y-intercept. Slope for each increase in one of your x values, what's happening to the y value, and y-intercept, tell me what's happening when x is equal to 0. And a lot of times that may not make sense in the context of the problem. Any questions about that? Okay, let's continue then. When you're dealing with a line of best fit, you have something that's referred to as a residual. Okay? A residual is the difference between the y value and then the corresponding y value on your line. In essence, what a residual tells you is the difference between your actual y value and the predicted y value from your point. And I'm going to talk about that when we look at another example. But keep in mind and understand what that definition of a residual is. In addition, when you're dealing with lines of best fit, you're going to have something that's called the correlation coefficient, which is R. That R value can be anywhere from -1 to +1, and that tells you how strong your relationship is between your data set. An R value that's close to -1 represents a strong negative correlation. An R value of 0 represents no correlation, and an R value of 1 represents a strong positive correlation. So if we look here are some examples of some scatter plots. You can see the different correlation that we have. Notice here we have an R value of 0.98. And look how closely your dots are to almost a perfect straight line. In your second example, your R value is 0.66. You can clearly see that your dots are going up, generally speaking, from left to right, but they're not as close together. Hence, your R value is not as close to 1. Here, there's basically no correlation. So notice that your R value is very close to 0. If we look at our bottom graphs, all of these represent negative correlations of some sort. Notice how close your points are to a line, and your R value is negative 0.98. Here, they're more spread out, but there's still a pretty strong negative correlation. So your R value is negative 0.66, and here your R value is negative 0.01. There's almost no correlation here. So the R value tells you that strength and that direction of the linear relationship between your values. I want to go through another example that's going to kind of put everything together in terms of our information. So I'm going to show you on this example here how to get all of our information using Google Sheets. Okay, which is another tool that we can use to create scatter plots and regression models and so on and so forth. So our year is our X and our attendance, and I think this is an amusement park or something like that, is our Y. So I want everybody to go to sheets.google.com. And we're going to use Google Sheets to create our scatter plot on this one. So we're going to go ahead and click a blank scatter or blank spreadsheet. And we're going to use Google Sheets this time to create that. So our X value is the year, and our attendance is the Y. So let's go ahead and we're going to label this as the year. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then Our Y value is the attendance. So in our second column, we're going to put attendance. And then our Y values, which are 850, 845, 828. And then 798. Okay. So I have this information. I've entered it into my Google Sheet. And now we're going to use Google Sheets to create the scatter plot. So how do we do that? We're going to highlight our data. We're going to go to Insert, and we're going to go to Chart. If at any point you've lost me, just speak up. This is not the chart that we want. We don't want a line chart. We want a scatter plot. So we're going to go down under where it says Chart Type, and we're going to go to Scatter.
Mr. Rosenblum?
Yes.
I can't really do this right now because I'm on my phone because my power's out.
That's okay.
I'm not on my computer.
That's fine. So we've got our scatter plot here. You can change some things in it, but we can see there's clearly a negative correlation here between our data. The good thing about Google Sheets is that unlike Desmos, it labels your X and your Y axis for you. So we have that X and Y axis are labeled in there, and we have a nice title in there. Now, I want to add in my line of best fit or my trend line. So I'm going to go to where it says Customize. And then I'm going to go to where it says Series. So I went to Customize and Series. And I'm going to click the thing that says Trend Line. Now it's showing me that line of best fit right in there. It hasn't shown me the equation in here. So I have to go ahead and where it says Label, I need to put in the equation. So I'm going to put Use Equation. And now it's going to show me that equation. I also want to know what that R value is, that correlation coefficient. Google Sheets doesn't show you R, but it does show you R squared. And we can get R by taking the square root of that. So I see that my R squared value is 0.927. If I take the square root of 0.927, I'll get my R value. So the square root of 0.927 is 0.962 or 0.963. So we have both our equation of our line of best fit, which is y equals negative 9.53x plus 844. And then we have our R value by taking the square root of 0.927. We get an R value of 0.963. So that means there's a really, or sorry, negative rather, because it's a negative. It's going down. So that means there's a really strong negative correlation here. And here's our equation of our line of best fit. Now we can interpret the slope as well. So what is the slope saying? Well, what is our X value? It's years. So for each year, what's happening? In this case, our attendance is going down. It's going down by 9.53. Okay, so for every year, for each year increase, the attendance, my Y value, is going down by negative 9.53. Now, your y-intercept here is 844. So your y-intercept is saying, okay, In year 0, the line is predicting that your attendance is 844. Notice that that's a little bit different from the actual, because your line is a prediction. It's saying the line of best fit, okay? What closely models the data. So in year 0, based on your equation, the attendance is predicted to be 844. Your line is a predictive tool, okay? It's a prediction for what it should be. It's not the actual amount. Does anybody have any questions about using the Google spreadsheet or the Google Sheets to create your scatter plot and get your line of best fit and your R value?
How do we make like the equation next to where it says attendance?
How do you get this to show up?
Yeah.
So if you have the scatter plot, you can go to Edit Chart. And under where it says Customize, you're going to click Customize. And then you're going to click where it says Series. So it's Customize and Series, and scroll down, and there's a thing that says Trend Line. You're going to click Trend Line, and then make sure that it's under Linear for the type. And then it'll show up right here.
All right, thank you.
Now, if you're more comfortable using Desmos, you can certainly use Desmos to get this. In fact, I can go straight to Desmos, and I can copy this table right into my Desmos. So I'm going to Control-C it, copy it right in. I don't even have to click Add Table. I can just copy it right into Desmos, and it'll create the Desmos equation or the Desmos scatter plot for me as well. And then if I want to get all that same information, Y1, the little squiggly tilde, MX1 plus B. And notice that you've gotten the same exact values that we got by using Google Sheets. Our M value, our slope is negative 9.533. Notice your M value, negative 9.53. Your y-intercept, 844. Your y-intercept here, 844. Your R value, negative 9.63. Everything is the same. So it doesn't matter which tool that you use. You can use Google Sheets. You can use Desmos to create the scatter plots. Just make sure that you're aware of the steps on how to do each of those. And as I said, it's very, very important that you're able to create the scatter plots and interpret the slope and the y-intercept. Now, one thing that I want to talk about is that idea of residuals, which we talked about before. So on Desmos, the nice thing is if you click that little plot next to residuals, it's going to create another column that shows you the residuals. Residuals can be either positive or negative, and what they show you is how far away your actual dot is from the predicted dot for that value. So for example, when you're in year 0, your Y value is 850, but the line is predicting that the Y value is 844.4. So the residual here is a positive residual of 5.6 because that's the distance from your actual point to your predicted point. So all of these values here that are above the line are going to have positive residuals. If I look at this point here, my Y value is 845, but my line is predicting that the Y value should be, I can get it exactly, 834.867. So if I take my actual Y value, which is 845, and subtract it by what the line is predicting, which is 834.867, I'm going to get the residual of 10.133. Notice this point here. That has a residual of negative 17.8. Why? Well, look at your Y values and the difference. Notice that this is way below what the line is predicting it should be. The line is predicting that when your X is 3, you should get a Y value of 815.8. But you actually got a Y value of 798. What is your residual? It's negative. How do I get it? I take my Y value of 798 and I subtracted from the predicted y value of 815.8 to get the residual value of negative 17.8. So all of these points that are below the line are going to have negative residuals. All of the points that are above the line are going to have positive residuals. And the residual is just the distance from your actual y value to the y value that is predicted based off of your line. Does anybody have any questions about that? Okay. So there's a lot in here that we have to make sure that we're aware of, all right? One additional thing that I talked about in the video that I want to reiterate to you is this idea of what's called interpolation and extrapolation. Interpolation means using your regression line to predict for values that are inside your range. Notice that this particular problem has x values from 0 to 9. So we should really only use our line to predict for values of x that are somewhere between 0 and 9. When you use your line to predict for values that are far outside of the range, that's what's referred to as extrapolation. And you could end up getting answers that are not accurate or not very close to what they should be. So you only want to use your line to predict for values in this area and here. You don't want to use it to predict for values that are far outside of that range. Any questions about that? So you should be able to now make a scatter plot using either Desmos or using Google Sheets. You should be able to find the equation of the regression line in both of those things, find the R value, and determine the type of correlation that's there, and be able to interpret the slope and the y-intercept. What we're going to be doing is we're going to be working on a project. There's a big ideas assignment, which when I'm done with going over the project, you can go ahead and get started on. And then if time allows, you can start thinking about the project, which we're going to work on all next class, but you can get a head start on today. So I want to go through that project. You can work with a partner on this, or you can work by yourself. It doesn't matter. I want to go through the steps of what your project is going to be. So step one, you're going to decide a topic for which you want to collect data. You should think about some things that you think there might be a relationship for. Then you're going to create a data table where you're labeling your X and your Y values. Decide how you're going to collect your data and then collect it. You need to have a minimum of 20 data points. You're going to create a scatter plot for your data. You can use Google Sheets, you can use Desmos, any other technology. You're going to find the line of best fit for your data and display it on the scatter plot. Once again, you can find the equation using a graphing calculator, Desmos, Google Sheets, however you want to. You're going to identify and interpret the slope and the y-intercept. Discuss if the y-intercept is reasonable. When we say interpret the slope and the y-intercept, that means in words like I did in the example earlier today. You're going to find and interpret the correlation coefficient R. So that's telling me what that R value is. Does it have a positive correlation, negative correlation, no correlation, and so on. Then you're going to choose any 3 points and find the residuals for those points. And then you're going to summarize your data and make a conclusion on your finding. All of these steps are going to be done using a Google, what can I think of it? Slides presentation, okay? So you're going to end up creating something, and this is on the homework post for today. Oops. There's an example in here, okay, that looks like this. So this particular example deals with the hours of spent at after-school activities versus students' pre-calc grades. You're going to show your data in a table. Then you're going to show your data in a scatter plot with the regression line shown. You're going to show your equation of the line of best fit, making sure that you're defining your y and your x values. You're going to interpret the slope and the y-intercept. You're going to create your R value, which is your correlation coefficient, and interpret that. Find the residuals for at least 3 of the values, and then complete your conclusion about what your data has shown. So this example is posted and you can use it as a model for what you're doing. You can either collect data on your own. So go to 20 of your friends, ask them, okay, maybe you want to do your amount of photos on your phone versus the amount of Instagram followers you have. Ask 20 of your friends, get the data that way. I've posted lots of stuff related to sports that you can use. So for example, maybe you want to use some NBA data and you want to look at the relationship between maybe the minutes a player plays. Let's see if this loads. The minutes a player plays and their points. So maybe I want to look at 20 players, pick how many minutes they played, their points scored, and go from there. Maybe I want to look at the wins for that team versus the 3-point percentage. And I want to do something like that. You can do that. Maybe you want to look at some NHL data. And the example that I've posted in the video dealt with the goals for versus the wins. And see, is there a relationship between the goals a team scores and the wins that they have? Before you start your project, though, I want you to make sure that you run by your idea with me to make sure that it's going to work. Okay, so that's what your project is going to be. We will have all of next class to work on that project as well, but if you want to get a head start on it, you can do that today. As I said, you can work with somebody else, or if you want to work alone, that's perfectly fine as well. Does anybody have any questions related to what the project is going to be?
When is it due?
The project will be due before class on Friday. So it needs to be submitted by class on Friday. So you can work on it tonight. You'll have all class. Wednesday, we're going to do one little activity, and then you'll have the entire class period to work on that, and then it'll be due by Friday. Any other questions? Okay, so for the rest of class today, you've got the big ideas assignment to work on. When you finish working on that, you can try and find a partner to work on the project with, and then just run it by me before you actually start working on who you're going to work with and what your project is going to be. And if you have any questions on the big ideas assignment as you're going through that, I'll be around to answer them.
Wait, are we supposed to do the Desmos first?
What Desmos?
The classwork.
No, the thing that says like guess the correlation?
Yeah.
No, you don't have to do that.
Okay.
We're going to do that next class. Maybe.